This is a quick tutorial on how to use standard hobby servos like this with an Arduino. A servo is nothing but a motor that's been geared down significantly, that's been attached to an arm that turns like this at a set rotation angle. What's special about them though is that they know exactly what position the arm is at and will constantly correct itself until it reaches that position. Servos like this cost around $15 or so. There are a couple of good companies. This is by Futaba, another one is High-Tech. And you can also get smaller ones like this from eBay for around $2 or $3. These apparently weigh 9 grams and work fine for smaller projects. The servo needs to have 3 connections: power, which is the red wire, ground, the black wire, and signal, which is usually a yellow or white wire. Power is usually 6 volts if you're using AA batteries. If you're using lithium polymer batteries, don't use more than 2 cells, which is 7.4 volts, because any more might fry the servo. The signal pin should be connected to the microcontroller, and it'll receive 5 volt pulses telling the servo what to do. This is the cable from the smaller servo. Notice how the signal cable is white instead of yellow. Also, animals like cats love to bite small wires like this, so don't leave them lying around, or you'll basically have a piece of junk. The circuit for this is really simple. We only need to use one output pin for the Arduino, which is going to be pin 9. So 8, 9. There. And plug that in. You can plug it straight into the servo connector. Bit tricky. And yeah, you want to use an external power supply. Don't power it off USB. You might be able to get away with it with the smaller servo, but with a bigger one like that, I wouldn't recommend it. You might blow the USB. So we plug this in to row 5, and ground, we'll just put it into row 10, and again use this to plug it in right into the header. Remember, the middle pin is power. I think that's standard for all servos, not just Futaba servos. And there it is, using 6 volts as power. And now let's get on to coding and write something to get it to work. The first thing we need to do is include the Arduino servo library. So we'll go under Sketch, Import Library, Servo. Then we want to create a servo object. So servo, we'll call it my servo. And we go to the setup section of the code. And we have to attach it to a pin, so my servo dot attach, and that's pin 9, so we connect it to. It's a PWM pin. And in the loop, we're gonna first write it to go to center. So my servo dot write microseconds 1500, which is 1.5 milliseconds, and create a delay of a second. We'll do this again to make it go all the way left, which, if you remember, is 1 millisecond or 1000 microseconds, and got the delay. And finally, we'll do this to make it go right, which is 2000 microseconds. And we'll check that we have no errors. Yep, so let's program it and see what happens. So I put a little marking on the servo arm so you can actually tell where the center is. And when we plug it in, let's see what happens. It's going to the center fine, but it's not going all the way left or all the way right. In fact, it can go much further than that. The problem here is that a lot of servos don't work right off the bat at the values of 1000 and 2000 microseconds. You have to give it slightly different pulses. It varies with each servo. So for this, I'm gonna guess maybe a an 800 millisecond pulse to make it go full left, and maybe a 2200 millisecond pulse to make it go right. So let's adjust those values in the code and try it again. So with the new values, you can see it's still centering fine because we haven't changed that value, and it's going almost to full left, but the right still seems a bit dodgy. So let's change the values a little bit more, maybe 700 to make it go full left, and 2400 to make it go right, and see what happens. With those values that we tried, we can see that the servo is working almost perfectly. So whenever you get a new servo, it's always good to test it out and write down those values. Most servos work pretty close. This one seems to be particularly bad, actually. But yeah, every time you get a new servo and want to use it, make sure you test it out with some code and actually note down those values. One thing I wanted to do was measure the current draw of the servo. So to do that, we need to take out some wires and create a break in the circuit, and make the multimeter go in series. So let's do that. And we'll turn this on to amps setting, DC amps, and plug it in, put the backlight on, and let's try this out. What's useful about these jumper wires is that they have little exposed contacts so you can probe it with a multimeter. Oh, it's not working because we didn't put it in the right row. There we go. So you can see it's not drawing all too much current, actually. Only about 0.2 amps at the most around. 0.224 actually. So a useful thing to do is you can set the min max value. So over here it's reading the max value, and we'll hold that. So let's focus. There we go. And probe it. So you can see the max value is read is 0.264 amps. Of course, that's going to change if you hold the servo down like this or make it work harder. So there you have it. That's how to interface a servo with an Arduino. One other cool thing you can do with servos is that you can modify them to use them as wheels for like robotics. It takes a bit of hard work, and sometimes you can't go back to using it as a normal servo, but this can be a cheap alternative to buying a motor driver and a regular DC motor. Here's a video of a project of mine that had 3 servos, 2 as wheels and 1 as a scanning servo. I've ripped it apart now, but you can see that you can actually buy wheels that fit directly onto the servo, and I've modified this so you can see that it's not, I've cut out the gear stopper so you can actually move it 360 degrees and more.